Hello everyone. Today we are going to learn about compound angle formulae in trigonometry. Well, not all of them, but a couple of them. So let's see. Okay. See, there are multiple ways to prove a theorem in mathematics. However, not every single one of them feels, intuitive. So in this video, we are going to learn a very intuitive method to prove compound angle formulae for sine angles. And yeah, let's be generous. Let's deal with cosine angles as well. Okay. Yeah. So for the sake of simplicity, we'll prove the compound angle formula for acute angles in this video. Okay. Now that we have set the stage, let's see what is given. Okay. Given sine of alpha and sine of beta, find sine of alpha plus beta. Okay. Similarly, we'll deal with given cos of alpha and cos of beta, find cos of alpha plus beta. So this is a bit tricky, right? Like, what do we know? We know sine alpha, sine beta, and in the other case, we will know cos alpha, cos beta. Fine. And we need to find what would be sine of alpha plus beta, cos of alpha plus beta, right? That's what we need to know. Okay, what do we know about trigonometric ratios in general? We know that trigonometric ratios are constant for an angle irrespective of the triangle they are in. So just look at this. In triangle ABC, okay, the sine of alpha would be BC by AC, right? And in triangle AB dash C dash, the sine of alpha would be B dash C dash by A dash C dash. So the ratio, that is, the sine of alpha, is not changing particularly. I mean, AB is changing, like AB might extend to AB dash and AC might extend to AC dash, but the ratio between these two quantities, that is opposite by hypotenuse, that ratio is constant for a given angle, right? So that's exactly what we are going to use. Now the method we are going to learn relies heavily on this fact. So let's get into construction and see where we are going with this. Okay. Now the trick is called mount and pack. So observe carefully. Okay. Construct a right triangle ABC. Okay. Here the acute angle is alpha. Now this ink blue triangle is there, right? ABC. That is our first triangle. Now place a second triangle on top of this first triangle. Look at the red one. Okay. That is ACD. Okay. Now this is also a right triangle, first thing. And second thing is that, by construction, we are actually using the angle here should be beta. Okay. So let me repeat. The first triangle ABC has the angle alpha here, and the second triangle ACD has angle beta here. What I'm trying to say is that alpha and beta share a common point, in this case A. Okay. Now this step is called mounting. You have mounted the triangle ACD on top of triangle ABC. So far good? Okay. Moving on. The next step is called packing. Okay. Now in this next step, we'll place the triangle CDE. CDE. Okay. This also will be a right triangle, and if you look at the way we are constructing this, I mean, we are extending BC towards E, and then we are making a parallel line to AB. That would be DE. So DE is parallel to AB. So that way we are getting another right triangle. And if you look at the angle, since this is alpha and this is right triangle, this would be 90 degrees minus alpha. Now this is again right angle, which means this would be alpha. Why? Because in a straight line, the total angle on one side will be 180 degrees. Okay, now look at the triangle CDE, this guy. Now this angle is alpha, which means the other angle should be complementary, 90 degrees minus alpha. Okay, now that is the construction, that is the first construction that we have done here. Now look at the second construction. What we are going to do is we are going to take a line, okay, parallel to BE, but originating at A, this point. Okay, starting from A, draw a line parallel to BE. So that would be AF. Now this can go up till infinity, right? Okay, so what we are going to do is we are going to cut it short by taking the line, or in this case extending the line ED parallel to BA. So ED will be parallel to BA and it is going to touch, or in this case intersect, the line we have drawn parallel to BE at the point F. Now this also gives us another right angle triangle, that will be triangle AFD. Okay, last time we have seen that this angle is 90 degrees minus alpha. In the triangle ACD, this angle is beta and this angle is 90 degrees. So the other angle should be 90 degrees minus beta. Now again, since in a straight line, the total angle on one side is 180 degrees, this angle being 90 degrees minus beta, this angle being 90 degrees minus alpha, this angle should be alpha plus beta. And consequently, since we have this as a right angle, why? Because AF is parallel to BE and ED is parallel to BA, and we have angle ABE as 90 degrees. That means these two lines are perpendicular. Similarly, these two lines will also be perpendicular. EF and AF are perpendicular. Okay. Okay. Now look at this carefully. By this construction, we get the rectangle ABEF. Why is this a rectangle? Because all four sides are 90 degrees. Okay. Now what is the one well-known property of a rectangle? Is that opposite sides are equal. So we have AB equals FE and AF equals BE. I mean, they are parallel, but since we have constructed a rectangle, they are also equal. Okay. Yeah. Now this step is called packing. Why should it be called packing? See, if you look at the triangle ACD, it looks like we have packed it into a rectangle. So basically we have fit it in a suitcase, right? Kind of. Well, technically even I don't know why this is called packing, but it looks like packing, right? So it makes sense. So let's just go with that. Now here comes the magic part. If you label each of these angles, like in all of these triangles and rectangles, okay, you will find that triangle CDE, okay, is similar to triangle ABC. Why? Look at the angles. Alpha here, 90 degrees here, 90 degrees there, 90 degrees minus alpha here, 90 degrees minus alpha here, AAA. So these two triangles are similar, ABC and CDE are similar. Additionally, now this is the magic and this is the best part, by mounting the triangle ACD on top of triangle ABC, we have produced a triangle that somehow, well, not somehow, basically by a construction, that has a sum of angles that we are dealing with, like alpha plus beta, alpha plus beta. Look at this. EF is parallel to AB and our AD is the transversal. And you can see that alpha plus beta are on internal alternative sides. So there you go, those are equal. So that's the idea. Okay, enough of revision of parallel lines and transversals, right? So let's move ahead. Now let's gather the sine and cosine of alpha and beta from basically all possible ways. Okay, so if you look at triangle ABC, we have sine of alpha as BC. If you look at triangle CDE, this guy CDE, we have sine of alpha as DE, opposite side, by hypotenuse CD, here DE by CD. Now cos of alpha, similarly from ABC we have AB, adjacent side, by hypotenuse AC, and similarly in CDE we have adjacent side CE by CD. Look at here, from CDE we have cos of alpha is CE by CD. Now for the angle beta, we don't have many triangles, we just have one, this guy. Look at this guy, all red and looking stupid. Okay, ACD. Now in this triangle, you see, what is the sine of beta? Sine of this angle beta, opposite side CD by hypotenuse AD, CD by AD. Okay, and what about the cosine of beta? Adjacent side AC by hypotenuse AD. So AC by AD. We have these 6 equations from this single construction or this single picture. Okay, moving ahead. Let's take this. Okay, I don't know if I can fit the picture, but yeah, let's try. Okay, so now what we are going to do is we are going to choose very carefully the terms such that the numerator and the denominator somehow cancel. Now from equations 1, 6, 4 and 5, how do I know these equations? Because I have prepared before this video. That's how I know it. Okay, no, all kidding aside, this takes a bit of intuition, and you need to do a bit of practice to get there. Okay, like who came up with this construction like the first time? Right, somebody did, right? So that was, I would say, a bit of accident. Okay, and later on it just became a habit. Okay, but the intuitive way of doing this is mounted back. Okay, so yeah, so if you ask me how did I choose these equations, well, I practiced. So first rule of trigonometry, practice. Okay, yeah, so take equation 1, equation 6, equation 4, equation 5. The basic rule here is, basic rule in picking the terms is that we want to pick those terms that cancel, right? Let's pick those terms. And also I know the formula for compound angles, right? Obviously, like why would I be doing this? Okay. And if in exam you get right, prove that sine of alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta, they are basically giving you the answer. All you need to do is prove. Okay, so basically you have the answer and I'm just teaching you how to prove it. Okay, so let's just go with that. Okay, so picking of the terms, understood? We want to pick the terms which get cancelled. Okay, I mean not all of them, the numerator and the denominator, by some combination they need to get cancelled. Okay, yeah. Okay, focus. So from equation 1, this guy, BC by AC, we have got sine alpha, and cos beta we are picking up from equation 6, AC by AD. There we go. And we have CE by CD. What is this representing? Cos alpha from equation number 4, CE by CD. We have picked up here. And we have CD by AD, that is sine beta. See, CD by AD. Now, in picking these terms, you can see that the denominator here AC and the numerator there AC. The denominator here CD, the numerator there CD. These do get cancelled. So we have BC from up here and AD from down there, and CE from up here and AD from down there. Okay, now pause a little bit. I know you know, basically know the proof by now. Let's just pause and think about how we are getting these cancelling terms from our construction. The trick is the hypotenuse in one case as the adjacent side in one case and the opposite side in another case. That means, for example, see, in the case of ABC, we have AC as the hypotenuse, but in case of ACD, we have made it adjacent side, right? Like by construction, we are making hypotenuse of one thing, which in case of sine angle and cosine angle, the hypotenuse becomes the denominator. We have made it the numerator for some other triangle. Like if you see ADC, right? So AC is the adjacent side in case of C. In case of this triangle CDE, CD is the hypotenuse. But in case of again our red triangle ADC, we have CD as the opposite side, right? So in one case it is becoming hypotenuse, in another case it is becoming opposite side. In one case it is hypotenuse, in another case it is becoming adjacent. So this is the trick. So this is why picking the terms that basically cancel in some manner or other helps us prove the theorem easily. So mountain pack, why is it easier? Because of the construction we are making in such a way that the adjacent side in one case, in one triangle, will be hypotenuse for another triangle. The opposite side in one triangle becomes hypotenuse in another triangle, right? Okay, where did we stop? Here. BC by AD plus CE by AD. Why? AC got cancelled here, CD got cancelled here. Now, BC plus CE. What is BC plus CE? Oh, they are on the same line. So this means this is B, right? BE by AD. Oh, AD, where did AD go? AD is this guy. We have BE, we have AD. Not in the same triangle, or I don't want to look at this trapezium. See, EDAB, this is a trapezium, right? I hate trapeziums. Like at least be a square or a rectangle. Why trapezium? Okay. So what we are going to do, we are going to observe that this BE is nothing but AF, in length that we got by construction, right? In the previous step. Okay, AF is equal to BE. These two sides are same in length. Okay. So by construction, I wrote by construction, but basically, after construction and realizing that this is a rectangle, you will get that. Okay, BE is AF and the denominator is AD. AD is this. Now look in the triangle AFD. In triangle AFD, we have AF, this guy, okay, which is what? Opposite side to alpha plus beta, and AD, the hypotenuse. We have opposite by hypotenuse, which is what? Sine of that angle. What is the angle? Alpha plus beta. So AF by AD is sine of alpha plus beta. So where did this begin? It began from here. Sine alpha cos beta plus cos alpha sine beta. This. And we have proved that this is equal to sine of alpha plus beta. So for acute angles, see, this we have proved only for acute angles right now. All angles are less than 90. Okay, for acute angles we have proved this. What we have proved? We have proved that sine alpha cos beta plus cos alpha sine beta is equal to sine of alpha plus beta for all acute angles alpha and beta. Got it? Okay. Now this is for sine alpha plus beta. Can we do cos alpha plus beta in a similar way? Yes, we can. See, we have the same construction, mount, then you pack, you get the same diagram, you get the same rectangle ABEF, and once you have this rectangle, you can prove that AB equals FE, opposite sides, AB equals FE and AF equals BE. Same thing. Now all you're going to do is pick the terms. Let's pick the terms. What are the terms? Let me place it right here. Okay, we are going to pick the terms. This time I am going to pick 3, 6, I mean from equations 3, 6, 2 and 5. Last time what did we pick? 1, 6, 4, 5. Here 3, 6, 2, 5. 6 and 5 remain the same. Why? Because for angle beta we have only one triangle. So 6 and 5 stay the same. Last time we picked 1 and 4. This time we are picking 3 and 2. Okay. Now again in the the exams, whatever the question they are going to ask like cos of alpha plus beta should be equal to cos of alpha cos of beta minus sin of alpha sin of beta. Okay, all we need to do is prove. So we have our LHS cos alpha cos beta minus sin alpha sin beta. Now from equation number 3, AB by AC. Now cos beta from equation 6, AC by AD. Okay, now from equation number 2, from equation number 2, DE by CD sin alpha, and from equation number 5, CD by AD sin beta. Cool. Okay, again why have we picked this? We have picked this to basically cancel the terms. AC gone, CD gone. Okay, now we are going to pick AB from here, AD from here, DE from here, AD from here. Okay, now AB minus DE. Now where is AB? This is AB. Where is DE? This is DE. Again we are stuck with the same trapezium. What did I tell you? I hate trapeziums. Now let's use the fact that we know. What do we know? We know that AB equal to FE. So what I'm going to do is I'm going to substitute FE where AB is there. So instead of AB I'm going to pick FE. FE minus DE by AD. Common denominator, right? Yeah, AD we have here. So FE minus DE, FE minus DE. So from this whole length we are cutting this length. What do we have left? FD. We have FD. We have FD by AD. Now these two belong in the same triangle, right? Now what is FD? FD is adjacent side. FD is adjacent side and AD is the hypotenuse. Fine. Now adjacent by hypotenuse, what is it? It is cosine. Cosine of what? This angle alpha plus beta from triangle AFD. So we have cos of alpha plus beta this one equals cos alpha cos beta minus sin alpha sin beta, right? For all acute angles. Remember, this proof, what we are proving here works only for acute angles. Obtuse angles, we'll come to that later. Okay, we'll come to that later. So for at least now, what did we prove? We proved the compound angle formula for sin alpha plus beta here, and we have proved for cos alpha plus beta here. Okay, let's wrap it up. Let's write it one more time, and that way we are good. So what did we learn in this video? Sin of alpha plus beta equals sin alpha cos beta plus cos alpha sin beta. Okay, similarly cos of alpha plus beta equals cos alpha cos beta minus sin alpha sin beta. Okay, now let's put it in a box and conclude this video. Box. Okay. Yeah, you know what, at the end of every theorem, what my maths teacher used to say, irrespective of what you have done, what you haven't done, you have to always write this. What do you write? LHS equals RHS. Has proved. Right? All right, take care. By heart this formula, I'm telling you. Okay, people who say by hearting is for losers, they are the losers. Okay, you need to by heart this formula. You have seen, right, how to derive this. Will you keep deriving this every time you need this? No, right? Just by heart it off. Okay, it's good to by heart. Okay, by hearting means you are having retention, you are having recall. So by heart these formulae, and remember the proof for acute angles. We will see if we can do obtuse angles sometime later. Okay, there is a way to prove that as well, but acute angles are easy. Okay, and I am lazy, so yeah, that's why we prove for acute angles. So yeah, that does it for this video. See you in the next one. Take care. Bye bye.